Welcome to The Explainer. Now, you've probably heard a ton about the quantum computing race, right? Usually, it's all about Google and IBM. But what if I told you the company that might be furthest ahead is one you hear about way less? Today, we're diving into Quantinuum and their mission to build a true quantum supercomputer.
So, with all these massive tech giants in the ring, who is really winning this thing? It's so easy to get lost in all the noise about qubit counts. But today, we're going to look at the company that's playing a totally different game. They're not just building better hardware, they're creating a whole integrated system, from the single atom all the way up to the final algorithm.
So, here's how we're going to break it down. We'll start with their unique full-stack approach. Then we'll dig into their absolute game-changing choice of hardware, the software that makes it all sing, what they're doing with it right now, and finally, their path to the Holy Grail, a truly fault-tolerant machine.
All right, first up, this whole idea of being a full-stack company. You really can't get what makes Quantinuum tick without understanding where they came from. See, they aren't just a hardware company, and they aren't just a software company. They're both, and that really changes everything.
This full-stack approach is pretty much their secret sauce. The best analogy is probably Apple. They don't just design the chips for the iPhone, they build the phone, they write the operating system, they run the App Store. Quantinuum is doing the exact same thing for quantum. That total control, that vertical integration, is a massive strategic advantage.
And this all kicked into high gear back in 2021. You had these two powerhouses, Honeywell, with decades of experience in complex industrial hardware, and Cambridge Quantum, one of the world's top quantum software and algorithm teams. They merged, and bam, just like that, you have the world's largest integrated quantum company, with the cash to back up their ambitions.
Okay, so let's get into the tech, because their whole strategy, literally everything we're about to talk about, hinges on one huge fundamental decision they made right at the start. It turns out, the type of qubit you choose to build with, well, it matters. A lot.
And this is it. This is the heart of their machines. Instead of trying to manufacture millions of tiny, identical circuits on a silicon chip, which is incredibly hard, Quantinuum uses something nature already perfected: individual atoms. They trap a single atom in a vacuum and use lasers to talk to it. Think about that. Every single one is a perfect, identical copy of every other one. No manufacturing defects. It's a huge deal. And here's why that choice is just so powerful. When you put their trapped ions head-to-head with the superconducting qubits that the other big guys use, the difference is staggering. We're talking about stability that lasts for seconds or even minutes compared to just microseconds. That's an eternity in the quantum world. The operations are more accurate, and maybe most important of all, they have all-to-all connectivity. That's a total game changer.
So you're probably asking, how do they get that all-to-all connectivity? Well, this is where the engineering gets super clever. They call it the QCCD architecture, but I just think of it as a qubit railroad. Instead of having the qubits stuck in one spot, they can physically shuttle these little atoms around the chip, moving them between different zones to do calculations or read out the results. It's genius, and it solves a massive problem that plagues other designs.
And the proof is right here in the numbers. Quantum volume is a way of measuring the real, usable power of a quantum computer, not just the raw qubit count. And Quantinuum is just crushing it. Look at that pace. They are on this relentless exponential growth curve, doubling their performance over and over again and leaving competitors in the dust.
But like we said at the start, this is not just a hardware story. You can have the most incredible quantum chip in the world, but if you can't tell it what to do, well, what's the point, right? You need a powerful software brain.
This is where TKET comes in. The best way to think about it is like a universal translator and a super optimizer for quantum code. It takes your algorithm and rewrites it to run as efficiently as possible. And get this, it's hardware agnostic. It's so good that other companies like BMW use TKET to run their programs better even on competitors' machines. That tells you everything you need to know. And building on that, you have Guppy. This is their next-gen programming language, and it's built for the future. As these machines get more powerful, the programs get way more complicated. Guppy is designed to be like a safety net for developers. It actually prevents you from writing code that violates the laws of physics, like the no-cloning theorem. It catches bugs before you waste precious time on the real hardware.
Okay, so we've got incredible hardware, and we've got brilliant software, but what can you actually do with it right now? Well, this is where it gets really exciting, because this isn't science fiction anymore. They are delivering real commercial value today.
So check this out, Quantum Origin. It solves a huge cybersecurity problem, creating truly random numbers. Your laptop just fakes randomness. but a quantum computer can tap into the actual fundamental randomness of the universe to create encryption keys that are, by the laws of physics, impossible to predict. It's not just random, it's provably random.
And again, this isn't some paper in a lab. This is a commercial product that major companies are using right now to protect critical infrastructure. They are basically selling quantum-proof security for today's world, getting ahead of threats from both classical computers and the quantum computers of the future.
And then you've got this science side. Their InQuanto platform is for quantum chemistry. You know, designing new drugs or better battery materials involves simulating incredibly complex molecules, stuff that's just too hard for our best supercomputers. Well, companies like BMW and Total Energies are using InQuanto to do exactly that, simulating chemistry at a level we've never seen before. Okay, all of that is amazing, but it's all building toward this one thing, the ultimate goal, the holy grail of quantum computing, fault tolerance. Qubits are fragile, they make mistakes. The real race is to build a machine that can fix its own errors faster than they happen. That's when everything changes.
And this number is just mind-blowing. For years, the conventional wisdom was that you might need 1,000 or more noisy physical qubits just to create one stable, error-corrected logical qubit. 1,000 to 1. Well, in 2025, Quantinuum showed they could do it with just 2 to 1. That isn't just an improvement, that's a completely different league.
And here's why that matters so much. They crossed what's called the break-even point. It was the first time anyone had ever demonstrated that their error correction scheme actually works, that the protected logical qubit was more reliable than the physical ones it was made of. That's the fundamental proof of concept, the green light you need to start scaling up.
So when you pull back and look at the whole competitive landscape, Quantinuum's path forward just seems clearer. While others are grappling with the huge overhead of their error correction codes or the physical limits of their designs, Quantinuum's qubit railroad architecture gives them a clear plan to just build it out into a 2D grid, almost like a traditional computer chip.
You know who else has noticed? The investors. When you see heavyweights like JP Chase and NVIDIA come in and help double a company's valuation to $10 billion in a single year, well, that speaks volumes. That's a massive vote of confidence in their tech and their path forward.
And they are not being shy about their plans. This is their public roadmap, and it's aggressive. They're basically saying, we're going from the error correction we have today to our first fully fault-tolerant machine by 2029, and then on to a utility-scale machine just a few years after that. They have a clear plan to build a truly world-changing computer, and they have the funding to do it.
So, let's go back to that question from the beginning. When will an entire industry be completely transformed by one of these machines? Well, looking at their full-stack model, their superior hardware, their real-world products, and their lead in error correction, Quantinuum is making a very powerful case that they're going to be the ones to provide that answer. And that's our explainer for today.